In this video, we're going to be talking about food deserts, not food desserts. That's a different thing. A food desert is a geographic area where residents' access to affordable, healthy food options like fruits and vegetables is restricted or even non-existent due to the absence of grocery stores within convenient traveling distance. In recent years, it's been cited that over 2.3 million people in the United States live over a mile from a supermarket where they can buy fresh fruits and vegetables. And that's generally not a good thing, because if you don't have access to a car and the only place within walking distance of you only has processed foods, guess what? You're eating processed foods. The data we're looking at today is from San Antonio, Texas. It actually comes from a Skew the Script lesson, so thank you, Skew the Script. So this data was gathered by looking at lots of different zip codes in San Antonio, Texas. Each dot on this scatter plot represents a different zip code, and for each zip code, the average household income for that area was noted, and then the number of organic vegetables offered at the grocery store was noted. A quick description of this scatter plot. I would say that it looks like a line. I mean, it helps that a line is drawn in there, but even without the line, it looks pretty linear. I would say it's fairly strong. The points are pretty close to that linear pattern. I don't know if there are really any outliers. Maybe those 3 points at the end, like the 140,000-ish income is maybe an outlier. But even that, I'm not so sure. It still kind of fits the linear pattern, so could be, but it's pretty close. And then obviously we can see a positive association. When household income increases, the number of organic fruits and vegetables offered also increases. Here's the equation of the line that describes this pattern, the best fit line, or the least squares regression line. What we're going to do in this video is just talk about the slope and the y-intercept. So let's start with slope. It's kind of crazy. The slope is 0.00096, right? Yep, that's 3 zeros. So if you're asked to interpret the slope, here's what you would say. For every $1 increase in the average household income, our model predicts that the organic vegetables offered will increase by 0.00096 fruits and vegetables. So this is basically Mad Libs. When it comes to interpreting slope, you can always use this sentence and you can just change out the details. The purple parts stay the same every time, and the green parts we change depending on the context. So for every one blank increase in your x variable, dollars, months, inches, centimeters, whatever it is, for every one increase in your x variable, the model predicts that the y variable will either increase or decrease by blank. And this is just the basic idea of what slope is, right? Slope is rise over run. When the run, or the x variable, increases by 1 unit, the y variable is going to increase or decrease by however many units. So that first number 1 is always 1. When your x variable is increasing by 1, tell your audience how your y variable is changing. In this case, if you earn $1 extra, the grocery store will offer 0.00096 more vegetables. Now, of course, a key word here is predicts. Like, this is what the model predicts will happen. It doesn't mean if you make $1 more, the grocery store is like, oh, better offer 0.00069 more fruits and vegetables now. It's like, it's a prediction. It's all based on the line. The y-intercept often doesn't make sense, but we can still interpret it. When the household income is $0, so if you have a house making $0, the model predicts that there will be negative 14.7188 organic vegetables offered. Once again, this is basically a Mad Libs thing. When the x variable is 0, whatever the units are, the model predicts that there will be whatever the y-intercept is. The y-intercept often doesn't make sense in the real world context. Like, this makes no sense. A grocery store having negative 14 organic vegetables offered, what is that? Like you are bringing them organic vegetables? It doesn't make sense. But the thing about the y-intercept is we need it to graph the line. So even though it doesn't always make sense, you need one in order to know like where your line goes. So if you're asked to interpret the y-intercept, interpret it just like this, even if it's nonsense. And then in a follow-up question, you'll be asked, is the y-intercept realistic or does it make sense in real life? And that's where you can say, no, makes no sense. The biggest mistake that students make when interpreting is not including enough context. So don't just say, when x increases by 1, y increases by 0.00096. Make sure you have context and explain what the x and y variables are. And yeah, this is a little bit of a concerning trend, because if there's only 4 fruits and vegetables available at my grocery store, what am I going to get? Fruit by the foot? That doesn't count. Those like vegetable crisp things, those aren't even vegetables. Did you know that? It's something we need to be mindful of. We either need more grocery stores with high quality fruits and vegetables, or we need better transportation for people to those good grocery stores that already exist. And also more food desserts. I would love more food desserts. No data needed for that one. More food desserts, please.